Welcome back to Animal Crossing New Horizons. I'm dear darling, and shall we see what's going on our lovely island of Fawnhallow today? Where we're going to put the... I've got a towel on my head, no headset, not headset, headphones around my ears. That's... How do I speak? Somewhere along those lines. Yeah. A bit of a later night episode today. It was a pub quiz time. The pub quiz has changed format into much more traditional pub quiz. How do we do? We came sort of like middle of a pack. Mainly because we had utterly atrocious music round. But we'll get into that in a second. And it's not, like I definitely didn't help contribute to a music round, so I'm not trying to like wash my hands of guilt. But good evening, everyone. Right now in Fawnhallow, it's 10:55 p.m. on Monday, April 7th, 2025. Yeah. I mean, I think I've spoken about the pub quiz that I do before. It was much more of a digital one, but now it's sort of changed back to sort of traditional pen and paper. Honestly, it was quite quaint. I thought it was quite nice. It was definitely a lot harder, mainly because the music round questions with like the people who I do the pub quiz with, usually obviously my friends, and we all went to the same school together, so we're all very similar age, and we all cover a very similar range of music that we know. And unfortunately for us, every single question in the music round this time was definitely of I would say an older generation. Not necessarily all of them much older, but some of them like definitely a decade or so, which can certainly make a difference. But anyway, like music round's never been my strong point. It's never one which I do particularly well at. No, normally it's a science nature one, which honestly I'm disappointed how I did. More so that I'm disappointed about if one of the questions was what's the boiling point of water in Kelvin, and I put 372 Kelvin, which upon reflection is definitely wrong. It is 373.15 Kelvin, and that is an answer I knew. But when I wrote it down, I wrote down initially the freezing point of water, and I put 272 because in my head I was like, I know it's like something 7 something. It's either 2 or 3, and I know it like repeats, and I'm pretty sure freezing point of water is 27 something, so it must be 272. Turns out the repeating part is when it's boiling, 373. But I definitely should have remembered that. And there's another science question which maybe I could have got, but honestly it was a really hard question. But it was like, what's a common name for hydrogenated magnesium sulfate? And I was like, what? Magnesium sulfate? Apparently it's Epsom salts, which, I never would have got. I didn't know, for one, I didn't know there was only one type of Epsom salts, actually. I was just thinking, I was like, magnesium sulfate, I was like, MgSO4, and I'm like, that doesn't really help me. And it's like hydrogenated, and it's like, what do I do with that? MgSO4 7H2O is Epsom salt. I don't remember how you balance it, by the way, how you put enough water on one side or another, but damn. That one I got wrong. But there's another one, which is like, what is common name for the bird called, the scientific name being pika pika? And I was like, I definitely know this because I've heard a bird called, I've heard like pika and birds before, but I couldn't think what it was. I guess it's starling. It was actually a magpie. To be fair, I wouldn't have guessed magpie, like, because what I've heard is like pika is like someone like corvidae or something. It's like a subcategory of corvidae, I think. So I probably would have put like a raven or a crow. That's my guess. Definitely wouldn't have put magpie. But yeah, if anything was disappointing, science and nature is normally around what I should do pretty well at. But I mean, to be fair, Epsom salt is a really hard one to guess. I think I put down like baking soda, and I was like, I'm pretty sure it's not baking soda because I'm like, baking soda is alkaline. I'm pretty sure magnesium sulfate is not alkaline. Maybe it is, I don't know. pH of MgSO4 3.5 to 6.5. Yeah, so it's quite acidic. What's baking soda chemical formula? Oh yeah, because when I was like, baking soda, I was like, is bicarbonate of soda. So I was like, I'm pretty sure that must have sodium and it must have carbon or carbonate in. So it's like, there's no way it could be baking soda. But I didn't have a good enough guess, to be honest. But chemical formula is very interesting, I think. It's actually one of the cooler things for some reason. In my opinion. Like, I did do A-level chemistry. So, I wasn't an expert at it. Like, I was not that great at organic chemistry. I was pretty decent at inorganic chemistry. Because it's sort of like maths disguised as chemistry, really. because there's like a lot about like balancing electrons and charges and things like that. Like a major part of, from what I remember, A-level chemistry is you get given like a reaction and you had to formulate what compounds come out of it. But there was a lot of like very different interesting things. Like there was something to do with that's organic chemistry, to do with free radicals. I don't know, I thought inorganic was very interesting, just like all the random like sort of reactions and stuff which take place and you had to remember. I mean, you get to sort of brag a bit if you can figure out how to name a chemical compound, you know the difference between butane and methylpropane. And the answer is both of them contain four carbon atoms, fully hydrogenated, so there's no double bonds. Just butane is a chain of 4 in a row, while methylpropane is a chain of 3, and there is extra hydrocarbon, CH3, off the one in the middle. See, it's different because it's an isomer. Same chemical composition of elements, but different arrangement. And you can brag, it's not much of a brag. I don't know, because there was always part where it was like naming things, which is very interesting. And I remember in GCSE chemistry we had a question on that, where we had to name hydrocarbons, and normally they're quite easy because it goes like methane, ethane, propane, butane, and then the rest go. Wait, I can't remember. Okay, what's 5 alkanes called? Pentane? Yeah, pentane, hexane, heptane, octane. Oh, something like that. Is that it? Methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Yeah. I don't know what it is past that. Undecane or something? But I remember we had a chemistry GCSE question where we had to name them, and then the final one, which was like an extra credit question, was like was the compound methylpropane. This is such a niche conversation topic which I'm talking about, but I remember it because it was written down there, and I remember like I was pretty good at taking exams, especially at GCSE time, like blitz through, and I got to that last question. I was like, what is this called? Because I was like, there's no way it's just called butane. I think I guessed methylbutane in the end instead of methylpropane, which I retrospect doesn't make sense, but also I didn't know what the answer was. And for whatever reason, that stuck in my mind. Because I was like, what an interesting question. I think it stuck in my mind because I was like, that was definitely an answer I could have worked out if I thought about it a bit more. Because I was really, really close to the actual answer. Anyway, how else does it go naming like alkanes or hydrocarbon things in general? Well, once you get to like a certain level of ambiguity, or which hydrocarbon like the methyl group is on, like if you're on, not methylpropane is obvious, methylbutane is also symmetrical, so it's fine. Methylpropane, you can either have 2 methylpropane or 3 methylpropane, depending on if it's in the middle hydrocarbon or one of the inner ones. If it's on the outer one, then it just becomes hexane. So there you go. None of this will make sense to you. I can't remember how they do the priority though. Like the numbering system, is that like it goes like from the most massive or something? I mean, you arrange it from like left to right. I can't remember. No, you take the longest chain and that takes the base layer, something like that. I don't know, but the thing is, you get a lot of random questions of being like naming this compound or naming like what this reaction forms, and they love hydrocarbon groups because they form so many things. You get alkanes, you got alkenes, which is defined by the double bond between the carbon group. You got carboxylic acids, which is defined by CO. It's defined by a double bond of O at the end of a group. And you got ketones, which is defined by a double bond with oxygen in the middle of a hydrocarbon chain. You got carboxylic acids. No, wait, hold on. Not carbon. But there's something in ketones. And also, this is definitely organic chemistry, not inorganic chemistry, by the way, because we're talking about aldehydes, that's it. Which is defined by the COOH bond at the end. But ketones is defined by it being in the middle. I don't know why they needed a different one, because to me they feel like they're fundamentally the same, but I guess they make different property veins. But it makes a difference in the end. And you have carboxylic acids, which are defined by COOH bond. Because then you have carboxylic acids reacting with aldehydes to make esters, which are one of the cooler ones because they're actually, something which you run into more obviously in day-to-day life because they make up like flavors and scents and things like that. I can't remember what happens when it reacts to a ketone. I don't remember much other sort of properties of it, but anyway, I feel like chemical symbols is always very interesting. It's always fascinating to see exactly how things get named, how you come about them, how you're going to name them, because there is a very sort of supposedly strict naming scheme in chemistry, because compounds can get very, very complicated. There's already like 200 or something elements on a periodic table. I'm not sure how many. How many elements periodic table? I can guess 273. That seems too high. 118. I don't know why I thought that was 200. Because I was picturing a periodic table in my head and I was like, there's no way that's 200 things. 118. Okay. Who knows? That could be a pub quiz question at some point. But yeah, I don't know. I feel like that was always my favourite part of chemistry forever, was understanding how the naming scheme works. I don't know. I guess it's like sort of, there's a nice orderly system to it, which makes it feel sort of rather satisfying once you can puzzle out the name. There's like a set of logic which you have to follow. And if you do follow it, when you get rewarded by the fact that it's like, oh, look at that. You get to see the fact that you've to write it completely from your own mind, or what it should have been, or what it is, I guess, literally. And you might say that's not that interesting. I think it's kind of interesting. It's almost sort of like, I guess it's not that interesting in much of it, like it's not in a particularly enlightening sense, but I think part of me finds it rather interesting the fact that it's like, oh, someone had to sit down here and come up with a rigorous way which covers all bases of like a naming scheme for chemical compounds. I'm sure there are exceptions as well. I'm sure like it runs into its own like shortcomings. So I'm not even sure if it's a universal standard. Hold on, what's it called? Universal standard naming chemical compounds. Chemical nomenclature. Oh, IUPAC name, that's it. IUPAC nomenclature ensures that each compound and its various isomers, which is sort of like the same constituent components but rearranged, have one formally accepted name, known as a systematic IUPAC name. But yeah, a lot of compounds have alternative names, known as a preferred IUPAC name. For example, white vinegars, commonly called acetic acid, but its formal systematic name is ethanoic acid. That's a really good example as well. Why is it called acetic acid? I don't know. But ethanoic acid is what it technically should be known as. I always find it very, very fascinating. Does it have rules on here? IUPAC nomenclature of chemistry. This is probably one of the more scientific ones, like conversations I ever had. Okay, we never got into this deeper level of naming. But Hans-Widman nomenclature? What on earth is this? Never even heard. Ammonium nitrate. Oh yeah, I was going to check. Bleach is ammonia, right? Chemical formula. No, it's not. It's sodium chlorate. What is ammonia? No, is it like bleach reacting with ammonia is really bad? Was it bleach and ammonia? It makes like mustard gas. Okay, that's what I was thinking of. Oh yeah, because bleach definitely has chlorine in it. Now I think about it, like it has to have chlorine. What on chemical reaction? What does it produce, which is so toxic? Dissolved ammonia and NaClO makes sodium hydroxide and ammonium chloride, I guess. Chloramine gas. Chloramine. Oh yes, because NH2 is an amine group, isn't it? Or something. I don't know. Chemistry I do find very, very fascinating, because I think it gives a lot of like explanation of like why fundamental things end up working. Like why are things like so toxic? And a lot of the times the answer is not so much that it's there and it just like, how to put it, like I guess when you think of like a toxic gas or something, you think of something like poisonous or whatever, but like how does a poison actually work? And a lot of times It's not always true, by the way, so don't take me for word of it. It's really just chemical reactions. It's like a lot of these things which are poisonous are, it's not so much they have like an inherent like compound in there, which is definitely the one which will always kill you if it enters your body or something. It's that a lot of times the properties of it are very, very reactive, which means it ends up reacting with a lot of chemicals in your body, which ends up completely disrupting a lot of things. Like, I can't remember. There's one of them which is like really, like it's something like how liquid mercury or something ends up poisoning you because it's like so heavy, and then it like takes up the space and like the areas, or like it binds to things pretty well, so it ends up meaning that your cells can't like do these reactions or something, and that slowly ends up, you know, killing you. I know it's a bit grim, I suppose, perhaps a bit macabre even to talk about it, but it really is fascinating, I think. Anyway, so bleach and ammonia. Okay, bleach is not ammonia. Now I think about it, definitely makes a lot more sense, because definitely bleach has chlorine in as something. Sodium hypochlorite. What's this IUPAC name? Sodium hypochlorite. Chlorite? I can't remember, because there's a way that you change the suffix of things, like chlorite, I can't remember. Chlorate means it's like an O3 group? No, O is an oxygenated group or something. Chemical naming H ending. Iode if it contains 2 elements, 8 if it contains 3 or more elements, one of which is oxygen. I can't see, that's too tiny. This uses Comic Sans. Ide, hydrochloric, I don't know. Hydrogen sulfide, H2S. Hydrogen sulfate, H2SO4. Which is also sulfuric acid, isn't it? Anyway, I don't know. I do find it like a very fascinating thing. Maybe I should learn a lot more about organic and inorganic chemistry to make sure I remember and figure out what's going on. Because if a science in nature comes up again, and I get the boiling point of water of Kelvin wrong again, I'm going to be highly embarrassed. I was actually quite surprised when I got it wrong, because I was like, I was really confident. Well, no, I wasn't like super confident. I was like, oh yeah, I think this is right. Like, it just sort of exists in the back of my mind vaguely. But then when I looked at the answers, we checked them afterwards what we got, and I was like, oh, as soon as I saw that it was 273, I was like, oh yeah, it is 273. It wasn't even that, it was more like, oh, I completely forgot that I put 272 initially. I definitely would have put 273 if I remembered it, which is kind of like how pub quizzes work. Anyway, the long and short of this is that IUPAC nomenclature, I think, is a very fascinating system. You know, there's a lot of like very fascinating things which feel completely, I think, trivially pointless to those of you who don't use it, right? Myself included. But it is very fascinating to learn about. Alkyl halides. I don't know if it only applies to hydrocarbon naming things, or does it apply to literally everything? Because this only says a list of functional groups. IUPAC nomenclature of organic chemistry. Okay, so it doesn't even apply to inorganic. How do you name inorganic compounds? IUPAC? Oh, IUPAC nomenclature of inorganic chemistry. Okay, so we just have 2 different systems. It's interesting, isn't it? I say, not knowing if you are all interested. Anyway, I guess I'll round this episode off here. I didn't really break down the nomenclature of it very well, because I don't remember it all too well. I just remember it existing. But that's, you can do further reading, I think, if you're an eager student and want to learn more. But for now, we're going to round this episode off here. So if you have been watching, thank you very much. It's been Animal Crossing New Horizons, and I've been Dear Darling. Likes, comments, subscription, shares, greatly appreciated. Socials, Discord down below. Hope to see each other again. But for now, it's our farewell. It's until next time. Bye-bye for now.